My name is William Coyne, and I'll be presenting on a dungeon crawler 3D level editor that I made using raylib and C++. So let's take a look. For the presentation, we have the following sections we're going to go over: an introduction, problem statement, project goals, tools and technologies, core features, technical implementation, a little visual demonstration, some of the challenges that were faced, future improvements if I were to release this commercially, for example, and a conclusion to wrap things up. So to get things started, of course, my name is William Coyne, and I have some past experience as a game developer hobbyist. I've been doing it for a long time, and I'd like to eventually do it as a career, probably towards retirement, realistically. Right now, I work for a hospital system as an engineer, but I have a pharmacist degree as a formal training and background, so I've definitely changed careers quite a bit. So that's me. Now, so the idea was to create a 3D level editor for a dungeon crawler type game. These things are somewhat of a niche style of game, and so as a result, we find it pretty difficult to get free tools on the internet, or even commercial tools for that matter, to make things like levels. Level editors in themselves are not that uncommon for game development. I think the most common type you'll see is for a side-scroller type game, a game like Mario, if I had to label it, and something like that, or a top-down view, something like Zelda or Mario. So there's lots of level editors for 2D tile-based games like that, but when you're looking at a more niche game like a dungeon crawler, which is an old school type of game, you really don't see anything out there. I think I've heard of one, and I'm not sure that it's available to use for free or even commercial, and there might be some licensing issues with the author. I don't know how they've released it, but that's something to consider as well. Is it free? Is it commercial? Do you have a license? Can you make something and then sell it commercially if that's your goal? So those are all things to consider. The reason a level editor is really useful is because it's going to save a lot of time. It's going to make visualizing and creating your levels for your game much faster, much easier, and it prevents having to hard code that data in your game, compile the code, run it, view the change, and then have to go back in the code and manually update it. That's a very tedious and slow process. You can do it, but it's just very painful and pretty unpleasant to do. So having a standalone 3D level editor for a dungeon crawler is going to just be a boon in that it will greatly help you advance and make levels for your game, which is an important part of your game. So the idea was to make a 3D level editor for dungeon crawlers, but make it generic enough that other people could use it as well, not just me. So it's not specific to any games that I've been working on. It's generic enough that you could use it for any other similar type game, if you so chose to. So the problems here, as we've stated, a lot of those problems already exist. The existing tools are made for different styles of game, or they have licensing issues, or they have a lot of features and complexity that are not necessary for what I need. That adds bloat. It also increases the learning curve. It makes it harder to learn. There's some free tools out there for different types of artwork, for example, that are so powerful that you would need a degree almost to get really good at it. So there's so much functionality that you're probably never going to use because nobody does everything. Most people specialize to some extent. So having a more focused and simpler tool can be great in that you can learn it very quickly, create things fast, and just stay really focused on one specific type of task versus having a huge enterprise suite of software that can just do kind of everything. You know, that's a very ambitious thing to do. Maybe something good for big teams, but not so much for individuals. So few options exist, and we talked about a lot of the cons of the ones that do exist, if they do. The goals of this, of course, was to create a standalone 3D level editor that was generic enough and modular enough that could be expanded upon, potentially released commercially or released as a free tool to the development community, whichever I so choose to do in the future. So I'll kind of decide that, and should be flexible and allow the development of 3D dungeon crawler levels. The tools and technologies that were used to create this, of course, Microsoft Visual Studio, C++, Crocodile 3D, raylib is the library, GIMP is an art program, and Sprite is another art program. Now I'm going to take a look at those real fast so you can get a quick look at the tools used to do this. So I should have those open. Let me see here. Crocodile 3D is just a 3D tile-based 3D editor modeling, 3D modeling program rather, and it's designed to work in a sort of tile-based universe which greatly simplifies things. Again, it's a very focused tool. It's not the most powerful tool, but it's very simple. It's made to work with lower poly model counts, pixel graphics, and work in sort of a 3D tile-based universe, if I had to say so. So this is not a free tool. It's like 30 bucks, but totally worth it and is a very focused thing. Great for what I'm doing. As you can see, if I rotate around this cube, you can see that was one of the cube tiles I made for the game here. So let's just close that out. And we're going to go to, this is a sprite. This is just an example of a button I made. And a sprite is designed to use pixel art. It's good at making sprite sheets and animation. It's also good at just making 2D art in general. There's some pretty powerful tools. This, again, is not free, sort of free. It's not free if you buy it fully packaged and ready to use. It's like, again, 20, 30 bucks. But you can get the source code and compile it yourself if you want, though it is a bit of a headache. I think it runs on Java, so not the easiest thing to do. But totally worth it to support the people that created this. So, you know, I bought the commercial one. Another piece of software I was using was GIMP. This is freeware. This is a more robust tool. It's more like Photoshop. So this can be good for 2D and 2D artwork. Is much more robust in that it offers a lot of functionality, a lot of tools beyond what I could need, but I use it a lot of times for layered things of that nature. It's not necessarily for pixel art. It can be used for any type of art, high resolution, low resolution. It's all around pretty good, but I use it for certain workflows. Again, free. You can use that. It's an alternative to Photoshop, which I'm sure everyone's heard of. Now we have, let's see, of course, Visual Studio and C++. We also have raylib. So if raylib is we'll go over to Visual Studio. Raylib is included in my project. You can see over here to the right as a separate project in my solution. So I have a solution with two projects in it. The first project is the level editor. Second project is raylib itself. Raylib you'll get from GitHub, and it's free. You can use it with any sort of language. I believe they have bindings in C, C++, C#, basically anything you could ever think of. They have a binding, probably even Python or whatever if you wanted to. Excuse me. And once you include that in your project and you build it from GitHub, that's going to allow you to have some more advanced debugging inside your projects. The authors recommend you get the full source code, put it in your project, build it with your project. So when you get errors in your troubleshooting, it's going to pull the debugging straight into the source code of raylib instead of giving you a more generic error if you were to link to it as a separate DLL file, for example. So what raylib is it's just an abstraction. It's a library wrapper for OpenGL. OpenGL is an API used to access the graphics card at a very low level for graphics programming, 2D, 3D. You can do games with it. You can do regular applications that have some sort of visual effect to them, which is most GUI applications, even in Windows. You could use it for that. It is possible. Though C++, for example, Visual C++ or Visual C#, they offer their own solutions in that regard. You could always use them, but you could write your own if you really wanted to. Usually it's used for graphical type programs, more like games, but other people use them for scientific simulations and the sort, not just used for games. It can be used for other applications when it makes sense. Now, what raylib does, for the most part, is simplifies a lot of using the OpenGL API. They offer a lot of built-in functions and functionality that help me speed along development, and I don't have to get stuck in a lot of verbose boilerplate code required to do things like open windows, things of that nature. Like when I open a window to render in, it handles that, which if you've ever programmed Windows back in the day, you probably know it takes quite a bit of code just to get a window open. It's the same for OpenGL. There's actually quite a bit of boilerplate code used just to open a window, for example. So in this case, if I zoom in, you can see there's a function here called init window. And this is a raylib function, and basically I feed it a width, a height, and a title, and it's able to open a window for me that I can render in. And it's easy peasy. I don't have to worry about a lot of those details. It just does it for me. So this is still a relatively low-level style of game development and game programming, in that we're doing it from C++, mostly in Scratch, but using a little wrapper library like raylib. This is a lot lower level than most people do nowadays. It's much more popular for people to use Unreal Engine or Unity Engine, which are, they still allow you to program a lot in C++ or C#, depending on the engine, but they're much higher level and built more on their suite of tools that they have. It's more like scripting in C++ and C# than it is actually programming from scratch. whereas we're getting a lot closer with raylib, though we aren't as low as you can go. The lowest, of course, would be using the OpenGL API raw by yourself, which you can absolutely do, but you're going to have to read some very thick books of like 2,000 pages long, and it's going to be a lot of work, and you'd be surprised at how difficult it can be just to draw some basic 3D stuff on the screen, add some shaders, add some special effects, a lot of blending, lighting, very complex. And you start to get into other things like physics, it gets really crazy. This is why not many people were able to make games themselves back in the 90s when games were just really taking off and becoming really commercial. It was very hard to make your own good game. Like if you wanted to make a game like Doom or something, or Wolfenstein, it was actually very challenging to make your own game because none of these tools existed. Everything was from scratch, and they were using very low-level functionality on the hardware. And of course, they had very slow computers back then, which was another limitation. So moving on, let's take a look at the presentation to see where I am here. All right. So that's the tools and technology. The core features of the level editor, of course, include placing tiles in 3D. It allows you to select a tile, or you can use the auto tile feature, which will automatically connect tiles together for you, but you can also manually override that by selecting the tile you want. We have our visualization, of course, displaying the 3D world on the screen and allowing you to walk around, and also having an aiming, reticule or aiming cube so that I can aim where I want to place the tile in the world. And then finally, we have saving and loading or serialization, in which we save and load the tiles that we placed in the world to a file so we can retrieve it later, or then load it into the game that we want and then, take it away from there and have fun with making our game. Now, the technical implementation here. So we talked about using raylib. This is for visualization and input handling. So raylib also handles mouse input, keyboard input. That's another complex thing you can do on your own, but raylib handles that. It captures it for you and has some built-in functions to tell, was the mouse clicked? Was it the left button or the right button, or which keyboard button was pressed? Is it being held down? And so on and so forth. Major techniques also include having a traditional game loop, and I'll point out how I did that a little bit later. Stack-based scene management, again, I'll talk about some of that. We used a lot of OOP principles, mostly in the form of simple inheritance, RAII. This is pretty textbook stuff. Solid principles and clean code, which are always good. Make your code modular, make it sort of, things are a black box and separated, all of those good things. We have, of course, a 2D user interface throughout our program. We use bit masks and such to select the correct tile. We use that in an algorithm to select the auto tiling feature. And then serialization, that would be the saving and loading of files. And again, we'll go through the code a little bit, but that was another major technique we used to get this to work. Okay. So a visual demonstration, of course, this is just a little slideshow, but I'm going to run the actual program right now for you and demonstrate that. So let's get going. So we're going to run this locally. We have a scene, a splash screen scene. We have an opening menu here. I made this menu. The background was taken from another game, so this is just a placeholder. That was the name of the original game that I'm making the level editor for, and then I decided to make it modular, but I just wanted something, aesthetically pleasing to look at here. So we have some disabled buttons to show what that's about, a start and quit, and then we also play a sound when you click. Transition into the actual level editor itself. We have a scrolling menu on the right-hand side to select a tile. We also have some visual information on the screen. We have an auto tile feature which we can toggle on and off. We can toggle the grid on and off. If we wanted help, we can walk around the world with the WSAD keys, and this green wireframe cube is essentially where we're aiming at, and that's controlled automatically based on where we're looking. It snaps the grid in the nearest valid position. So once I select any cube here with auto tile on, I can press the space bar and start drawing tiles. The red here is just visual feedback we give to the user based on the location of these tile cubes, and you can see with the auto tile feature, I am simply placing the same tile over and over, and then the program automatically selects the appropriate one to make an adjoined room. So once we get out of here, we can actually place some enemies in the world using the keyboard as well. All right. And then what we can do is if you hit backspace, you can delete. All right. Now I'm going to hit F5 to save it, exit out, restart it again. I'm going to hit F9 to reload it, and then we can see that the level that we had placed previously is back and ready to use. Wonderful. So we can also scroll through this menu here, manually select tiles and override. We don't need to use auto tile, but auto tile just saves a lot. Auto tile is just a simple algorithm. And very quickly, I will show you the tile file that we saved. This is actually our save file. And what we've done here in our serialization is simply place the three-dimensional coordinates. We place things like, this is the colors, the 255, 255, 255. This is basically white with an alpha of 255, so it's solid. There's no transparency. And then we go with essentially I believe the first number is the model index. So this is which particular cube model to use. Then we have three-dimensional coordinates, x, y, and z. And we have a scale. This is so every cube is multiplied by 10 in scale or size. And then that's the information. Then, of course, the color information. And then it just saves one of those for each tile placed in the game. And when it reloads it, again, we can go through that a little bit. All it is reading each line and pulling each element out one at a time. And it knows that this means which model to use. This is the 3D coordinates. This is the scale. And then we have, I forget what the last one is off the top of my head, but then we have the colors, of course, as well. Oh, yeah, that was the red one. That's why it's 230, 40, 155. Those are the red tiles we were seeing. And then the 255 one, this is the regular tinted one. Okay, so that makes sense. And then basically we go through that one by one. We collect these in variables, and then we just create a new tile object and feed in these elements into the constructor. Easy peasy. You have serialization. Great stuff. Now let's go back to the presentation. So the challenges I faced were, of course, the complexity of having a standalone level editor. I've never made anything like that before, so this was a new project for me and a new challenge. I feel like it sounded very difficult when I first started, but I was able to break down each individual feature into a smaller problem and tackle it that way. And that was why I was able to finish it and get everything done. And it actually wasn't nearly as bad when approached in that method. The user interface I found very challenging and very time consuming. So I was getting buttons working in there. The whole user interface is done from scratch. There really is no user interface functionality in raylib, so I created all of it. So that was pretty tough. I got buttons working. I got callbacks for the buttons working, meaning you click a button and it calls back a function, and it uses sort of an observer pattern, so it doesn't need to know anything about outside objects if you're not familiar with programming patterns. So there's some separation there. Serialization, something I thought would be more difficult, but turned out to be really easy in that I kind of explained how that works. We just take the properties of a tile object and then write them all out one at a time, and when we want to retrieve it, we load them all one at a time and create a new tile object and feed in those parameters in the constructor. Very simple. And then visualization, actually showing and displaying everything in 3D, having the player able to walk around and place things. Of course, that was another challenge that we faced, but we were able to tackle all those. Future improvements, things that I would like to see in here that are not in here already. I'd like to be able to edit the properties of an object, including a tile or an enemy, control how much health the enemy has, how much gold it's carrying, make a tile as a trap or make it passable or impassable, so on and so forth. I'd also like to see an undo and a redo button. That would be very nice. I'd like to see the 2D user interface greatly enhanced and better. I'd like to see a more robust user interface, something that just looks a little better. I'd like to add some mouse aiming in there and make that a little better. I think it could use some documentation and a tutorial to help people get oriented, and then some variations in tiles to allow the player to put more than just one type of tile. So adding cracks in the wall, vegetation, rocks and debris, placing things around, maybe put some banners on the wall, just allowing the player to really customize things and make them stand out a little better. So what did we learn from all this? So we had a large project. We were able to break it all down into smaller chunks, and that's what helped us stay up on the deadline here, finish things on time, and get this relatively complicated project done. I avoided gold plating things. That's implementing features that I might need in the future that I don't need now. That's very helpful. So the KISS technique, keep it simple, minimum viable product, that sort of thing. Don't go gold plating everything. And another lesson learned, should you do this? Should you do this from scratch instead of using Unity or Unreal Engine? I would say yes and no. Yes, if you're very serious about this. No, if you're more of a hobbyist, because it is a lot harder than using someone else's engine like Unreal or Unity. But the pro is that you're going to learn a heck of a lot more than you would if you used one of those engines. But you can still make games in those other engines that make really good ones, but it's way quicker and way easier, but you also don't understand as much because more of it is hidden in the engine itself. So the project was a success. I feel like I achieved the goal I wanted to, and I feel like I can enhance it relatively easily to add those missing features that I think would be useful. So the development will definitely continue into the future. It was a little bit easier than I expected from just thinking about the idea, so it really wasn't as bad as I thought it was going to be. And then eventually I'd like to release it either commercially or just with a game for free and just include it as a separate level editor, that sort of thing. Or I could just release it for free on my website or something like that. It might attract people to my website, which could be a nice way to get traffic by offering a free tool that people could use. Learning outcomes, I think I got a little better at object-oriented programming, some of the techniques used there, clean coding, being modular, memory management in C++ was big. I really wanted to do this in C++ because I always want to improve and get better at memory management. I think that's really important because a lot of higher level languages, you don't have to even worry about memory management, which I think is not great. That I think more people nowadays won't really have much understanding or ability to do any memory management. I think that's a real weakness personally. And then of course, serialization I thought was going to be a lot harder than it was, and it turned out to be pretty easy. And I feel like I could apply this to really sort of anything in the future. Values provided, I think, again, a simple, efficient workflow. It's going to save a lot of time. It's going to make it very easy for me to load and use for any game I make in the future. I could make a lot of different types of games similar to a dungeon crawler or something like that. I think I could use this for any of them. So that's very useful, and there's few to no alternatives that exist out there right now. I recommended a few books. These are things that I use to learn throughout this process and that I would highly recommend you take a look at if you have the time or interest in game development. These are probably some of the best core books that you can get on either C++ or game development in particular. And we're not doing this live, so there's no questions, but if anyone ever does have any questions, send them to me. Of course, I have an X profile here. It's my name, WM Coin. You can say hi or just track development if I post things in the future, or just get connected because, we're all going to graduate soon if we're in this class. So let's see. Other than that, that's pretty much it. I don't want to get too much into the source code, I suppose. I have done that previously in other presentations, but I think that will pretty much cover it. But if you want to take a quick look at this, I guess one thing I'd like to explain that might be of interest is the core game loop. I like to talk about this, and this is right here, essentially, where the program just loops over and over again to run instead of running once and ending. And what we use is the stack-based scene management, where we have a stack of scene objects, and then the object or the scene at the top of the stack is the one that we render on the screen, the one that we get input from, the one that we update from. So that's all it does. It basically calls a scene manager, which then grabs the scene at the top of the stack, and this allows us to very effortlessly switch between scenes. It's a very useful technique and something I didn't really know until I started doing this. So other than that, most things are pretty standard. I think the user interface stuff is pretty standard. Programming, anytime you're doing any user interface programming, it's going to be like that. Scene management might be a little bit unique because you might be using visual software like Visual C++ or Visual C#, and in which case you just call a function and it like loads the next form. You don't really have to worry about this sort of thing. But if you're making games and stuff, you do. We also have some other functionality built in here. A cooldown system, that was pretty neat to write. The serialization, the actual loading sprites from a sprite sheet. For example, I have a sprite sheet for the mouse. And then these are the individual scenes. We have the level editor itself, the main menu, splash screen, and so on. You could also add like a pause screen or an options and about screen and so on. You can string those all together using the stack-based scene management. You have your enemy, which all the properties you would have of an enemy. Right now there's only one goblin, and you would just simply flesh that out. You could make a base, you could break this out and having a base class, an enemy base class, and then you could have a goblin child class, and then have different types of enemies, and then do your standard inheritance like that. Very sort of common sense approach to doing that. And I'd say, and that's pretty much it. And then basically we're loading and placing all our cubes. There's a lot of helper functions in here. And navigating around in a 3D world. So that's a whirlwind version of the code. I don't want to get stuck in there too much. I believe I attached all the source code and stuff to the InStructure website. And so if you're curious, take a look. Anyway, thank you very much for your time. I think that will cover it. and I had a lot of fun, learned a lot of stuff here. I think this project was pretty cool. I'm happy I was able to do a subject like a level editor. It was really cool. So anyway, thank you and have a wonderful evening.